Welcome back to my channel. My name's Brian Kafferke, and this is the first video where I'm interviewing somebody on a technical subject. The opportunity to interview Daniel Zafar, a deep dive technical expert on Databricks, was too good to pass up, so I'm opening up a new idea on my channel, if only for him. Daniel was somebody who helped me with my book. He particularly helped me on the chapter with Spark R, which he has worked on. And a short background on Daniel is that he has worked on many different areas within the Apache Spark platform as a software engineer who works for Databricks, helping customers troubleshoot whatever problems they happen to have. And since he works with some of the largest customers of Databricks, he hits pretty much everything. So this was too good a chance to ask lots of nerdy, deep dive technical questions. This is not your marketing brochure. This is not your sales pamphlet. This is going to be technical. I hope you're as excited about that as I am. And my first subject area I wanted to talk to Dan about was the architecture of Apache Spark and Databricks, which, as you know, are really kind of one and the same, since Databricks is a wrapper around Spark. And then I really wanted to look at the difference between Apache Spark and Snowflake, because those are really kind of two big competing products on the big data stage these days. And I wanted to get his take on what are the technical differences and what are important things for customers to be aware of. So let's jump in, and thanks for watching. Hello, everyone. I want to welcome you to the first interview on my channel. So this will be great. We're going to be interviewing someone from Databricks, Daniel Zafar. And before I get into introducing Daniel, what I did want to do is mention a couple of things to a little bit of guidance, I guess, pre-interview. One thing that you may not be aware of is Databricks is essentially a user interface wrapper in the cloud environments around Apache Spark. So generally speaking, anything you say about Apache Spark should apply to Databricks. Not necessarily the other way, but definitely that way. That's first thing. And there's other bells and whistles, you know, the notebooks, et cetera, that go with it. But when questions are being asked, Daniel understands that I'm actually asking them in a sort of Apache Spark way. And then if they don't apply to Databricks or there's some difference, he can clarify that. Okay. And the other thing I wanted to sort of say is that it's understood to make it easier for both of us that whatever's said is really more of a technical opinion, professional opinion, not something that Daniel, I'm assuming, has gone to Databricks management and said, is this the official policy? Is this the strategic direction? And I say that because I know, having worked at Microsoft, I never really knew what their strategy would be 5 years down the road or where they were trying to go. I only knew what I knew at that point in time. And so I'm putting that disclaimer in unless Danny wants to contradict that. My introduction.
I think that's perfect.
Great. So I actually first became aware of Daniel from when I was writing my book, Master Azure Databricks Step by Step. And I needed help on the R part of it. There are two competing packages, Spark R and Sparkly R. And I'm not sure exactly how I found out, but I saw Dan's name somehow associated with Spark R. And then I hit him up on LinkedIn and said, can you help me? And he was extremely helpful. I got to thank Dan for that. It was extremely beneficial to the book because I was able to run material by him. He actually looked through the chapter I was writing, and I made a lot of corrections, I think, related to that avoided putting things out that would be wrong to people reading the book. So thank you for doing that. And yeah, so a little bit of background on Dan. You can talk to Dan. Thank you for being here. But Daniel, yeah. So Daniel is a software engineer who works at Databricks and basically works customer facing. So when there's the deepest, darkest hour and there's problems on the customer sites getting things working on Databricks and Spark, he's called in to troubleshoot, get things moving, and put a solution in. That's why, in particular, what's great and why I'm excited about this is because this is going to be a technical discussion and not a marketing hype kind of thing. We'll actually get into a lot of nitty gritty and that kind of thing. And that's what I'm excited about. So I'll let Dan introduce himself because he'll do a better job than I will. So, Dan?
Yeah, just quickly, sort of my role at Databricks is I sort of have this unique place where I have to be extremely technical on a lot of different areas of Spark and Delta and Spark streaming and all of that. Sort of what I do is just like what Brian was saying is I field lots of different technical sort of issues. So basically, if somebody has a Spark streaming job that just stops running, like it's ingesting data from some Kafka sources and stops running, what's going on? If there's some issue, some glitch on ADLS Gen 2 that caused some file to be malformed and it, blew everything up, how to fix that. So it's a pretty fun position. I'm in the backline team, and so we feel just sort of the really kind of like more difficult, nuanced issues. A lot of them end up becoming bugs that we try to solve, or give to the core engineering team that specializes in that particular area. Yeah, that's sort of my job in a nutshell.
Okay, and you work across all three clouds?
Yeah. I haven't personally gotten started too much on GCP, but I expect those will be rolling in pretty soon. So
Yeah,
because it's a new functionality for us.
Awesome. All right, That's great. And what I saw your title. I don't know if you can remind me. And I was having a hard time figuring out exactly what it meant, but it might be good for people to just know what the title is.
For sure. Yeah, it's a little bit of an esoteric title. It's called Backline Spark TSE. TSE stands for Technical Solutions Engineer. And so I'm sort of, I deal with, I'm in the support org, and I deal with the really difficult sort of issues that arise. But with the Spark, machine learning, R, PySpark, and Delta sort of use cases.
All right, great. Well, thank you again for coming to do the interview.
Of course. Yeah.
All right, so I'm going to start with kind of high level questions, but they are also technical. One of them is, what do you see as being the medium to long-term technical / architectural direction of Spark?
This is a good question. When you ask this, my first thought is, I'm not 100% sure, because, it's a very mature framework at this point. You can do quite a bit with it. And I feel like some of the improvements are happening in sort of related projects like Delta. But that being said, I think when I've asked some folks internally about this, it really looks like the progress that we focus on is not so much in the core functionality of Spark, like creating additional core functionalities, to be more on the PySpark and SQL side. So one thing, for instance, that is really important to us that's like recent that we've been working on is getting ACID transactions with SQL into Spark. So it behaving a little bit more like in RDBMS, right? And then with PySpark also just making things easier and easier for people that are coding in PySpark. So it's a lot more similar to coding in Python. For instance, there's a related project that Databricks is heavily invested in called Koalas. So with Koalas, you can just code in pandas and it'll sort of transpile into Spark.
Does that really work? It just seems like too good to be true. When I read that, I'm like, really?
I would expect to get a lot more issues related to that than I do. My guess is, it does work, certainly, and the team is actually very prolific with it. I feel like every other week they're like releasing a new version. So I would definitely, if you haven't checked that out or coded with it, I'll definitely check it out. There's a few nuances to it, because with pandas data frames, you have indices, and in koalas, there's a few different types of indices that you can apply. And so understanding sort of how those work, some of the indices will be, for instance, distributed and other ones are not. So sort of having an idea of how that works, you can scale up your pandas code into Spark really nicely.
Nice, which is great, because I think we talked earlier, like Python is the most popular language now on Spark. And so being able to make it easier for people is just going to make it that much easier for people to adopt it.
Completely. Yeah, that's also sort of an interesting thing about Spark is that you can do the same thing in a million different ways. like the APIs are sort of set up that way where you can just, there's so many overlapping APIs. So we've really tried, and the open source Spark team has really tried to make it something that's very easy to code in.
Yeah, no, I've seen that. And there's even a good deal of overlap when you get to R as well. You can use Sparkly R or Spark R. You can use data frames, and it seems to be they scale up. But I've got a couple of questions for that too later. So
For sure. Yeah.
yeah. Okay. You mentioned something which is perfectly leads into this question, which is I can see that there's sort of this Spark came along, and initially Spark did not have any SQL support, and it used the resilient distributed data set as the abstraction. And then Spark SQL got added, and that really became sort of a data engineering core for doing data frames and performant processing. Along the same lines, of course, we now have Snowflake and Synapse, and these are really just taking a relational database and scale them out. So what I see is sort of two different ends coming at the same problem in a way. Mm-hmm. We're getting sort of a data warehousing like functionality. And I guess, where do you think this is heading? And do you think there's going to be a point where there's a sort of overlap where they do almost the same thing and that kind of thing, where it's just going to converge?
Yeah, completely. Yeah. So the way that I normally explain this to customers who are a little bit curious about the two different paradigms of Snowflake and sort of like Databricks is, you can think of sort of like the life cycle of what you're doing with data, right? Like the beginning of the life cycle is you're streaming the data from, sensors or different sources or transactions if you're in retail or what have you, like a million different sources. You're streaming all of these sources in, and they're sort of going and sitting on some sort of storage layer. And then on that storage layer, they then get merged into some sort of, they get cleaned up a little bit, and then they get merged into, bigger tables. And then from there, they get merged into other tables, so on and so forth. And then finally, they land in some sort of other destination that will feed the BI, it feeds the data scientists, it feeds the modelers, the analysts, all the sort of downstream consumers. So if you think about this sort of full life cycle, right? Like what Databricks did is like we started off on this end. We started off on how can we do this part at scale, like with Spark. That's what Spark does. It's like, how do we do this at scale? And then we also wanted to bake in everything to be able to do not only the ETL, as throughout the years, we also we recognized the great thing about having everything on these files is you can do machine learning really easily with it. So we made machine learning as being a very core part of what we do. And traditionally, this end of how do we have really performant data warehouse like functionality was less developed. Versus Snowflake was sort of the opposite. So they were focusing on, let's just get the data warehouse scaled up so big that you can just have everything in this data warehouse. And the machine learning aspect is something that was always a little bit weaker, right? Because it just supports SQL. You only have access to the data that's already in Snowflake, right? So now Snowflake is doing a lot of work to see how can we build all this machine learning functionality on top of our existing data warehouse. And so basically Databricks, everything's a data lake, and it turns into like a data lake house once you put Delta on top of it, and it feeds machine learning models like perfectly because you can use any open source, anything in it, and it's all on your own storage in the cloud. Versus Snowflake is everything's a data warehouse. You don't need the data lake. The data lake is messy, don't touch it. And so where I think it's sort of going and converging is that there's definitely an overlap here, and I would consider Snowflake to be sort of Databricks' biggest competitor. I think I'm allowed to say that. And so
my perception as well. So
yeah, and so the idea is that Snowflake is nice because it's a really simple UI. It's definitely something that's geared towards people that are using SQL day in, day out. And so, and it also has some good speed. And again, like, I'm not a marketing guy, I'm not a sales guy, so I'm just gonna say sort of what my opinion is here. But no, I'm probably biased because I work for Databricks, right? But the downside of of Snowflake is that everything is going to be housed inside of Snowflake, right? So it's like you have to send your data to Snowflake, it's sitting in Snowflake. And if you want to take it out to do other stuff with it, you have to like export it, you have to like query it with the JDBC or whatever, right? With Databricks, everything is just sitting on, if you're on AWS, it's all sitting on S3. If you're on Azure, it's all sitting on AD less than 2, right? Yeah. Like it's just right there, and you're just doing all your operations with it. We talk about like the data lakehouse with Delta. It's just Parquet files. You can read that with from wherever you want, right? So the main things that Databricks has been doing is how can we get all the sort of really nice, like streamlined, user-friendly stuff that Snowflake has. And we're actually, we're just announcing some of that stuff tomorrow, which will be way beforehand whenever this interview is shown, but at the Spark Summit. So like, we're offering now like, enterprise data governance, data sharing, stuff like that, where before, Snowflake would be able to say things like, Databricks is great, but if you really want data governance, if you really want, all these sort of advanced sort of enterprise features, security, you need to use Snowflake. Now there's not really any sort of kind of ground for them to stand on in terms of that like competitive viewpoint now, because our main focus has been, let's make Databricks simple ever since I've been with the company. And then trying to get it super, enterprise, level and data governance and all those things. So anyway, that's just my take. But does that answer your question?
Yeah, and I think to paraphrase it, what I heard is there's both use cases, and I thought that was a great way to approach it. From sort of Databricks sort of started from the landing of raw data and then cleaning it up and getting it better and better to process with. And you're right, I mean, relational databases was where Snowflake really came from, so that makes sense. They started with perfectly ingested clean data, but that means you have to ingest it, which means you have to add a lot of overhead in all cases. Whereas I see with like Spark, you can leave it as schema on read, and you may not want to ingest it if you're just going to push it through and do analysis. But what I also read in there is closing the gaps is the direction. So there's certain strengths that Snowflake has, and Databricks is looking to close the gaps. It's already got strengths, but now security is one. And the thing that occurs to me also is that within an environment like Spark on say Azure, with Azure, you can do a lot to improve security as well. You can use like Key Vault for securing IDs, and with the ADLS, you can secure it to some extent, et cetera. So, because I've seen those criticisms, and they kind of ignore what the cloud service itself can offer to close some of those gaps too.
Right. And yeah, and then just to be 100% sort of transparent here, as of tomorrow, May 26th, when we do, it's in the past if you're watching this now, but I feel like Databricks actually has closed all the gaps. Like we have everything that you need. We have everything from, being able to bring stuff in, all the stuff that we historically have done really well. We have the SQL analytics, which is sort of like your SQL box where you can just go in and write SQL code in a serverless environment. We have all the enterprise grade security and everything that you need, governance, data sharing, and then you can do all the sort of modeling that you need. The one thing that I think that we're missing, and I'm excited for, is Delta needs to have some better connectors, I think, downstream. So right now we're working on really ramping up, like, let's get as many open source contributors to Delta as possible.
Nice. Okay. So by connectors, things that can natively read in and out and process Delta Lake.
Exactly, because a lot of people say, hey, this Park, I'm going to run everything in Delta, and then I'll store it in a Parquet file at the very end. I'm like, why would you do that? You're giving away so much functionality. Schema evolution, all these great functional, like all the ACID transactions, all that, like, what are you doing with it? Oh, well, my downstream application can't read Delta yet. I'm like, oh, it can only read Parquet files. Okay, I guess that makes sense, but hopefully in 6 months or 8 months, that's not the case.
Okay. So something I think, I'm not an expert on Snowflake, but what I've looked at trying to research also is when you use something like Python with Snowflake, they have a connector, but it doesn't look like it's able to run Python on the nodes. It has to use SQL on the nodes and then bring the data to, I guess, a Python local data frame to do something. So it doesn't look like it can scale out Python natively. I'm pretty sure that's correct. I could be wrong. So if somebody watches this and says I'm wrong, they can tell me otherwise, but that's what it looks like. When I've seen demos, they always write SQL code and pass it through Python to get data back. So anyway, I want to thank you for watching this segment of the video with Daniel Zafar, a deep dive technical expert software engineer for Databricks. Please continue to the next video where we'll get into more details. Until then, I'm pulling for you. We're all in this together. Thank you.